So, well, when you come in, I was just fixing my demo, and I tested everything twice, and then you walk up to the stage and it doesn't work as intended anymore. So, I'd like to go over a use case from a Dutch customer and do a live provisioning demo as well. So for the people that don't know open networking and what it's all about, I think that you've been down here at the booth and you pretty much saw the open hardware from Facebook, EdgeCore, and there are some other vendors as well who have OCP hardware. But the idea is that you can choose hardware from those providers and you install an operating system on top of that. Obviously, I'm biased because I work for Cumulus that you should choose Cumulus as an operating system, but it gives you the same freedom that you have for your servers today, that you can choose what OS you run on top of that. Now, if you look at the hardware that is available, I sent in the slides and the OCP guys said, well, why are you mentioning all those other vendors? What is the idea with this? And the thing is, if you look at hardware development, there are only 6 or 7 ODMs in the world who actually produce the hardware. So people are then asking is, what do I get when I buy this hardware? What is the difference in hardware quality? And it's actually the same what you get. So if you go to the OCP website and you download a design for one of the models, that's basically how a Cisco or Juniper also let their hardware being produced by one of those ODMs. So they make a design, they go to that ODM, and the ODM produces it. Now, those same ODMs, they usually have subsidiaries. The Acton group, for example, has EdgeCore as subsidiary. Celestica, I'm not sure if it's a direct subsidiary, but Penguin is related, and they have open hardware as well. But with OCP, you can download the specs, and should they decide to, not to have the hardware anymore, you can even have it produced yourself. Most of the open compute hardware or networking hardware is running on Broadcom chipsets. I have the standard logo of the Trident chipset here, but there are other ones. And most recently also the Trident 3 chipsets that Cumulus supports as well. Now, I'd like to go a bit over the design, how you put that all together. If you look at how you design networks, and that's both for standard vendors and for Cumulus as well, and OCP hardware, is that you build spine and leaf architectures. Now the question is a bit, how are you going to scale, and how do you make larger network topologies? Now one of the things that you saw that Facebook is doing, that they make a new rack platform, so they can scale out and have larger spine leaf architectures. One of the options that you have is you build an additional tier in your network. So you have several pods that, depending on your application, they should be independent of each other, and you build a super spine. Now that super spine, for example, you have a Facebook backpack that I'll go into detail more. But that allows you to scale out, and in this case, a pod can hold about 24 racks, depending on the port density of the switches. So you can see how this can scale out for an entire topology. Now there's also another option that you can connect your super spines directly to your spine switches. That will cost you a lot of cabling, and depending on how you configure your network, for example with EVPN, it might not be the best scalable solution either. But if you look closely at the design here, then you might think, okay, that looks like a line card in a chassis, and the super spines might look like fabric cards. Now that is exactly the same what Facebook and EdgeCore thought. So they build chassis devices that look exactly like this. So if you look at the Facebook backpack, for example, I took these photos in our lab about a year ago. I think that's actually Scott's hand holding the line card here. But the line cards actually have two ASICs. So that means that it's actually two switches, providing you 32 ports on the front end of the line card, and also the same amount of bandwidth on the back side. And you physically connect them into fabric cards, and that means in the end you'll get a spine leaf topology inside a single box. Now, this is an image of the OMP, the edge core box, but for Facebook, for the backpack, it's quite similar. That means that you have a one-on-one oversubscription, and it's all directly connected, so you don't have the cost for your cabling and optics. If you look at the topology that I showed you earlier, if you would build this one with separate boxes, I was at the customer and we were calculating the cost for the optics. It was optics and cabling alone, it was 250K extra if you wanted to connect it like that. Now, what I'd like to do is I want to show you a demo. I'll quit the presentation for a bit because I want to start it up, and while testing, it took a bit longer than I expected. So while it is provisioning, I'll show you some more of the slides. So what I have here is I have a Facebook backpack chassis, and I'm going to provision that using Oni, which is the bootloader. Right now it's fully booted, and I'm going to use Ansible to give it a reboot, and then I'll show you with some slides, and while it's busy provisioning, I'll show you well, how it's being provisioned and such. So what I'll do is I'll run an Ansible playbook, and that will basically reset the Oni installer so that it will reboot all the devices and start the installation of the OS. Now, I've made a few small windows. You can probably, read them. You see that the top four are the fabric cards, and the other four are the line cards that you can see. Now, these are all console options, and there are actually 8 line cards. Or at least there are 4 line cards, but they're split in 2. But I can only show you one at a time. So you just have to trust me that the other 4 are also being provisioned at this moment. Now, how does that work when they are being provisioned? Sorry. So when a line card or a separate switch boots, it boots into Oni. And Oni will go through a waterfall trying to find an operating system install image. And in this case, what we did is we used the HTTP to give an additional option with the URL for the installer image. And that option 239 allows it to get that image over HTTP, install it, and start the installation. Now let me see if it's already a bit there. Oh. So you see that it is booting right now. The one that you can read takes a few more seconds. But then you should see that the installation is starting. Now you see that it's doing the DHCP request here. I hope it's readable for some people. It's going through the waterfall, and I hope that it will use the DHCP option. And what you'll see here is that it got this URL through the DHCP option, and it will download that image to start the installation of, in this case, Cumulus. So right now on all the line cards, it will do an installation of Cumulus. And well, I'd love to stand here and show you all a progressing bar. but we'll assume that that will go all fine. Now, a little bit about Cumulus. Cumulus Linux is a Linux-based operating system, and it's a fork of Debian Chassis. So right now that's stable Debian, and Debian Stretch is the next stable of the version of Debian, and we will be integrating that in 4.0. Now the important thing is what you saw earlier with Sonic presentation is that you need to program the hardware based on, in our case, free-range routing. Well, you are migrating there, I hope to. But we are using the Linux kernel for all the forwarding information. So in our case, free-range routing sets up BGP sessions, and if it receives prefixes, it will program them in the kernel. But then our switching daemon looks at that information, the database, and it will program the ASIC based on that information. Now, one thing that's quite important for us is the automation features because it's Linux. That means that you can use all the DevOps tools that you are already using without changing them. So you don't need any modules from Cumulus. You can use the standard templates like with, for example, Jinja 2 if you're using Ansible or SaltStack as well. And you can build your templates to provision all the devices. Now, we recently have a new customer here in the Netherlands. And that's actually a bit of a different use case. Because normally Cumulus focuses on data centers, but I gave a presentation about a year ago, and some guys from Naturalis, the National History Museum here in the Netherlands, they approached me like, hey, we like Linux, but we want to build a new museum and we need a campus network for that. So they actually are building right now the physical building, and there will be a very cool T-Rex in there. The campus network will be providing connectivity for all the devices that you can think of in that museum. Now, one of the things that they like to do is all the automation around it. So they are building a new physical museum, and the thing is with building a new infrastructure around a museum and all the devices there is that you need to do very fast provisioning, because there's a guy who wants to set up the alarms or some specific museum exhibits, and well, they plug it in and it needs to work. So and usually they want to have it working yesterday. Now, one of the things that they are doing is that they, for special devices, they register MAC addresses, and they can provision it in the correct VLANs using their Ansible automation. Now, I hope that the installation is almost done, because what I'd like to show you then is how I make a spine leaf topology with Ansible as well. It seems that it's still rebooting, so I have to talk a bit more. Well, perhaps in the meantime, I can answer some questions that someone might have.
We want to get you on the mic, not for the speaker, but for the recording.
Hi, Stefan. Regarding the automation possibilities, are there APIs available onto the switch? So like a REST API to tell the switch what to do or how to configure it itself?
So currently we have an HTTP API because we have a CLI in there, but we don't have a REST API yet. We are looking into the possibilities of netconf with OpenConfig, but it seems that the decision hasn't been made yet in how people want to use that. But because it's standard Linux, you don't really need a REST API because you can use your templates as well, or something like Ansible. You can install an agent So you can directly configure applications like you would normally do.
Okay, so I can install a daemon built by my own, which renders templates or
Exactly.
consumes REST calls and render the templates to config files.
Indeed.
Okay, thanks.
So I actually gave a presentation last week where I'm pulling data from Netbox, which is an open source administration tool, and I'm pushing that all that configuration through Ansible into a topology. Well, that goes a bit beyond the demo here, but yeah. Now, it looks like they're almost done booting. So I made a small script to check if everything is ready. Not all of them, apparently.
Can I ask a quick question about the DTP? So you said you're using option 239?
Yeah.
So that's based on what? Is it based on the MAC or based on the serial number, or what is it based
on? So 239 is it doesn't base it on the MAC. Well, you could do that. So what we did in our lab, we have a DHCP server, and it has all the line cards, MAC addresses, and then it provides the correct URL.
Okay. So the provision is based on MAC address.
You can
when you assign the IP address, that's based on the MAC.
Yeah, okay. You could do that. But in ONI, it also has other identification possibilities. Most of the customers use either MAC addresses to identify a device. But if you look at ONI, if it starts to download the image, in the HTTP request, there are other identification possibilities, serial number or device type that you could provide a correct image for.
But where do you gather the MAC address in the first place? You have to, your DHCP server have to have the MAC address. So where do you get the MAC address of all the line cards?
Well, at some point, someone has to enter a MAC address in some system if you want to identify a device, or if you work with serial number, same thing. Yeah, so you have to get that physical. That's
yeah. Thank you.
In this case, all the line cards have a sticker on them that identifies the MAC address. That's how we get that.
Okay. Yeah, so separate switches usually have a label as well. No, let's see if it's done now. Almost all of them. So one thing that I'm also doing is the first time that Cumulus boots, it has a process called zero-touch provisioning. And zero-touch provisioning allows you to execute a script. So the first time that it boots, it gets another DHCP request with a different option. And you can provide a URL to a specific shell script or bash script, Perl, Python. And you can install several things. Now, given that I need to log in with Ansible, what I did is I'm uploading the SSH key so that Ansible can log in as well. No. Almost done booting. So the thing is that while testing, what I saw is that in some cases it couldn't download the image, and it had to go through an additional waterfall, and it took a bit longer to install. But it seems that my timing was still a bit off. Okay, so what I'll do, you see that one line card isn't booting or not reachable at the moment. So what I'm going to do is I'm going to run the Ansible playbook anyway, and that means that one of them isn't available, but I think we'll survive that. I'm running a deploy script, and basically what that does is it is changing the free-range routing configuration, so all the IP routing, and it will change the interface configuration. In this case, a backpack has a default configuration which allows it to be used as a spine. But what I did in my Ansible configuration is basically showing how you could make a layer 2 device with it by using EVPN on top of that IP fabric. So that means that I changed the default configuration, enabled EVPN as well, and that would allow you to build VLANs or encapsulate layer 2 over VXLAN as well. So what you see is that it's provisioning all of this, and let me log in the meantime as well. So except for the single line card, all of them were okay, and that means that the configuration files are replaced. I can show you that quickly here. In this case, EC network interfaces. I've created 2 VNIs as well, and the according VLANs. Well, explaining EVPN in detail, that will take another hour, but if you want to have more details, then feel free to come to our booth. We have a nice book on that as well. But that means that the switch is now reachable, and it should have all the BGP sessions up and running as well. So if I do a NetShow BGP sum, on this line card, you see that there are 16 BGP sessions to all the line cards. So that means that it's balancing traffic as well. In this case, this is for IPv4. And I also enabled the EVPN address family. So that means that right now it's also exchanging information about the VXLAN tunnels. So let me quickly show you that as well. If I show a NetShow route, it will show you the routes to all the loopback addresses of all the line cards in there. And that has 16 different paths, so over the different line cards in the chassis. And you see that all the next hops are IPv6 because we are using BGP unnumbered. Again, I'd be happy to explain that later as well. But if I, for example, have a look at let's show EVPN. At the VNIs that I'm distributing right now, you see that 2 VNIs, they are configured on the local system. And if I then have a look at the routes that I'm receiving, then you see that all the line cards to each other are advertising those VNIs as well. So that means that you see a route distinguisher here, and again that is available through all the paths over all the line cards as well. Now that is basically what I wanted to present here today. Let's see if that other line card is alive right now as well. But if there are any questions, I'd be happy to answer them as well.
Any questions?
A question on the BGP, the EVPN.
Yeah.
So your internal fabric is running BGP also, or running OSPF?
BGP.
Yes.
Yeah, so we have something called BGP unnumbered, because typically with BGP you have some kind of underlay. But with BGP we have point-to-point links, and we're actually using the IPv6 link local addresses. So on every link, it has an IPv6 link local address. So what you see here is one of the links to the backplane. but you could see that as a spine switch, and you see that it only has an IPv6 link local address. And we are using router advertisement to detect who your neighbor is. So if I show you the configuration of the BGP configuration, let me show you that. Then you see that you only have to point at your local interface. In this case, the local interface is FP0 until 15. And also for the AS number, you can define it as external, which means that it has to be different than your own AS number.
But is there an assumption that between the fabric and line card, there's only one BGP session?
No,
one device or
so
one
each line card has 16 BGP sessions.
But two different backplane, right?
Yeah, so a backpack chassis has 4 fabric cards.
Yeah.
And it has 4 links to each fabric
So each
card.
link have a BGP session?
Correct.
Okay. So would you end up having ECMP problem inside the fabric? If you lose a link and the other link are still up, would you need to deal? How do you deal with the ECMP?
Well, then you would have unequal balancing. But if you lose physical links in a chassis, I think that well, you should you have a problem with your hardware.
Okay.
Yeah.
Okay, I think we're out of time.
Okay.
Thank you, Attila.
No problem.